This is as expected. It should be quiet for a little while, at least. We're now 5 minutes to entry. Continue to receive heartbeat tones. Everything is good. At this time, curiosity should be up to about 5.5 kilometers per second.
Not until after we hit the entry point will we actually begin to feel the force of the atmosphere gradually building on that heat shield. So really it's still a spacecraft. It hasn't actually become an aircraft, but and that means it's ready to go. And as soon as you start feeling the atmosphere, it'll start doing its role to get to the turn as part of the guidance that it does. It starts off with a right bank, and eventually will make a left bank, and then make another right bank as it makes its way. And that's where we're getting tones from that vehicle right this second. And we're not getting Odyssey data yet. It doesn't happen until a little while later.
After parachute.
Actually, after, during, just after entry, about the time before parachute, just before parachute opens up.
Medial phase dynamics.
The network ends.
Go ahead, dynamics. Just FYI, OD227, runout looks like missed distance of 232 meters. Over. 232 meters? That's correct. Less than the divert. Roger. We can expect a brief signal dropout when we switch to the TLJ. We're at 3 minutes to entry. At this time, MRO should begin picking us up. But remember, we won't get that data for a while. It's got to store it and then send it back down here for us to decode. We're still seeing heartbeat tones. Everything looks good. Spacecraft should be up to 5.6 kilometers per second. Entry.
The EDL team is reporting that the latest runouts, which is using the latest nav, our best guess of where we are, show us that the best guess of our landing target location is about 232 meters from the landing target. So, looking good so far. We're continuing to receive heartbeat tones. Everything looks good. We're about 90 seconds from entry.
Flight dynamics EDL phase. Go ahead, phase. That last solution was with 227 or OD228? That is OD227. Thank you. You guys have now OD228 in your possession? There will be no 228 for us, phase. That's just fine because the difference is in spitting distance. Affirmative.
The vehicle will switch antennas shortly. We'll have a short dropout when that occurs in the tones. Switching to a tilted antenna that will be used for entry. drop that in case we change the tennis.
We're seeing heartbeat tones again after the switch. Things are looking good. Got tones back again. On entry. Hit or course entry interface. At this time, we'll begin pressurizing the propulsion system to increase the thrust of the system. We'll use that for all the maneuvering in the atmosphere we're about to do.
Back target zones.
We're standing by for guided start of guided entry. Here, as we go in here, the vehicle just reported via tones that it has started guided entry. At this time, the vehicle is beginning to steer its way to the target. And starting the first next one. First angle complete. We have seen peak deceleration. We have passed through peak heating and peak deceleration. It is reporting that we are seeing G's on the order of 11 to 12 Earth G's.
Flight GSA.
GSA flight go.
We are processing data from Odyssey.
We are now getting telemetry from Odyssey. All right, reversal 2 complete.
Copy tank reversal 2 complete.
Next.
Standby flight. We have a connection, but we actually do not have any data yet.
wrist mode dynamics.
Wrist mode is nominal. For 9 kilometers in descending.
Please exit. Downrange.
That filter converges with a velocity correction of 0.7 meters a second. We will fire the ground with the radar.
Now to the 8 kilometers.
Visual has separated where we found the ground command zones due to recycle location as expected. We're getting by to prime the MLE engines in preparation for power play. We're down to 90 meters per second at an altitude of 6.5 kilometers descending. Flight EDO, we got some torpedo warnings. It is in battle short mode, so it should power go. Director of communications at this time. We may have lost Irvin. We're down to 86 meters per second at an altitude of 4 kilometers descending. We've lost tones from Earth at this time. This is expected. We're continuing on Nazi telemetry. Ground solution equals minus 10.8 meters. Vertical velocity of minus 80. We are climbing 8 meters per second. Start enabled. Standing by for batch cell separation.
Signal velocity is still strong.
We are in powered flight. We're at an altitude of 1 kilometer descending. About 70 meters per second.
Signal velocity in the air.
Down to 50 meters per second. 500 meters in altitude. Standing by for skycrane. Constant velocity accordion nominal. Altitude error 5.9 meters. We've got a nice flat place. We're coming in ready for skycrane. Down to 10 meters per second. 40 meters altitude. Skycrane is started. Descending at about 0.75 meters per second as expected. Expecting throttle petrol leak.
Signal velocity remains strong.
Tango Delta nominal.
You go home, configure.
Where you stable?
Telemetry.
Where you stable?
UHF is good. Touchdown confirmed. We're safe on Curiosity will take us. At this time, we're continuing to receive telemetry from Curiosity. We're safe.
The surface of Mars.
As sequence is kicked off, waiting for images. Heads up, folks!
PL off. The signal to Odyssey remains strong.
Flight radio, all images are starting to come down. So we got images coming down, Chuck. We do a configure stand by for images.
See thumbnails coming down.
Odyssey data is still strong.
Odyssey data is very strong.
Odyssey sights high in the sky. At this time, we're standing by for images. Thumbnails are complete.
Got thumbnails.
Holding
Okay. So here we are. We're going to start. Go ahead.
Okay.
So we have landed out at the time we thought we would, and we now have our first image.
We have our first image. This we've got is a 64 by 64 thumbnail. A rear has-cam image. You can see the shadow there. I'm not sure exactly what our orientation is of the vehicle, but we're looking through it. I think in just a few minutes we might get even a larger 250 to 256 frame pixel image of that same end. So we're looking at the shadow. See, the horizon is actually in the distance. You can't really tell that. So we're looking at the shadow of this late afternoon sun.
So these are the rear house cams.
The rear half cams.
And it does have a dust cover on it.
It does have a dust cover, but it's the dust that covers the problem. It's the fact there's dust in the air because we have just blown dust all over the place with our descent engines.
Fantastic. So there could be more.
There could be more. If we wait, we might get, oh yeah!
Ah!
This is the 256 by 256 image. This is the higher res. You see dust particles on the window. You can see the horizon there in the background. And there is the wheel of the rover safely on the surface of Mars. I can't believe this. It's unbelievable. We might get another one of these, and if we're lucky, and before Odyssey goes away, we'll get 2 more of these images going the other side of the vehicle, and also probably dusty. This is amazing.
So that is one of Curiosity's rover wheels
Exactly.
on the surface of Mars.
Yes. Oh wow! Now we have another image coming down. This is a view looking the other direction. It's still being processed. You'll see it in just a second here. This is another thumbnail image.
Is that a shadow?
That's the shadow
Of the rover.
Curiosity rover on the surface of Mars.
The Odyssey transition is about to end. It's about to set below the peak of Mount Sharp very shortly. So this is about all the data we're going to get, but things look great.
Congratulations.
Thank you very much. Thank you.
different target location on this current fly through. If anyone in the MSA is online, you should watch this fly through.
Administrator of NASA, Charlie Bolden. Welcome and congratulations. We're on Mars again.
We're on Mars again. I'll tell you, it's just absolutely incredible. It doesn't get any better than this.
What was it like for you? Were you on pins and needles? It's suspicious we
I
were.
was a basket case. I was really on pins and needles, and you know, it was the irony was we were sitting there saying we know we're on the ground, We just don't know what kind of shape we're in. So to hear the calls come, seeing everything was all right, it was great.
And how about seeing the pictures?
This is, that's incredible, and it's a huge day for the nation. It's a huge day for all of our partners that have something on Curiosity, and it's a huge day for the American people. So, as I told people as we went around earlier tonight, everybody in the morning should be sticking their chest out saying, "That's my rover on Mars," because it belongs to all of us.
Well, that's what I'll be doing tomorrow
Well,
morning.
you should do that.
Well, thank you so much for dropping by. I know that you are getting ready for a news conference.
We are.
We are so glad and so pleased you could join us.
Well, thank you very much, and thanks for carrying us through this whole thing and making the public able to see what's going on here. I've been watching you, and it's been great.
It's a good day. All right. In a moment, we will have Dr. Charles Alachi, but let's go back to the room for a bit.
Dynamics, this is Hayes.
Okay, so you're on page 91 in the procedure.
Roger. I'll hold everything there so we can see
All right, it is my distinct pleasure to welcome with us President Obama's Science Advisor, John Holdren. Thanks for joining us. It was such a pleasure to have you join us for this big landing.
Well, I'm very happy to be here tonight. Very happy to have seen this incredible accomplishment with this Mars landing.
What does this landing mean for the nation?
Well, it's an enormous step forward in planetary exploration. Nobody has ever done anything like this. We are actually the only country that has landed surface landers on any other planet. But this lander is vastly bigger, vastly more capable, much more complicated to bring in. Many new technologies had to work in perfect succession and perfect synchronization for this to happen. It was an incredible performance by the Jet Propulsion Lab, by NASA, by the teams around the country who had contributed to this, and indeed partners from around the world.
So what does this mean? What future implications could we be seeing in this now that we've landed on Mars?
Well, this is by far the most capable device set of instruments we've put up there for determining whether Mars ever could have supported life. And of course, the question of whether there was ever life on Mars is an enormously important scientific question, almost a philosophical question, relating to our place in the solar system and our place in the universe. So we stand to learn a tremendous amount from this Curiosity Mars Science Laboratory. It really is a portable science laboratory. It's going to do incredible things.
And with all science experiments, with all science, when you get some answers, it just leads to more questions.
It leads to more questions, and it's always the way of science, but it leads to ever more interesting questions and a larger body of knowledge from which those questions emerge. And we know that the space program has for decades been very important to the United States. It's been important economically. It's a driver of innovation with widespread applications, but it's also a source of inspiration to the next generation of young people who are going to become the scientists and the engineers and the technicians that ultimately will land people on Mars.
Right. These are the footsteps leading to that.
Absolutely.
Well, Dr. Holdren,
Pretty crucial.
thank you so much for joining us. I know everyone's excited. There will be a news conference at about 11:15 our time, Pacific time, and it's a good day, and thank you for being here.
It's a great day. Thank you very much.
All right. Thank you so much.
Okay, Dynamics. Flight director is ready to copy. We have a touchdown time of 10:14:39, which is in PDT. Sorry, I apologize for that. UTC is required in the pole, so you can do the conversion. Stand by one. You got a little roger on that? Let's see, step 730.013. So we have a touchdown velocity vertical of negative 0.607398 meters per second. Step 14, touchdown velocity horizontal 0.044365 meters per second. Expected fuel remaining at flyaway. Sorry, Bentoma, we have 140.6 kilograms. For step 16, we will need photo confirmation of descent stage location. Step 17, offset between rover z-axis and gravity vector of 4.37 degrees.
Yes.
And finally, in step 18, we have our navigated lat-long calculation, which is negative 4.591817 degrees, longitude of 137.440247 degrees, and that gives us a navigated range to target of 2.279.
All right, well, they are in the midst of the post-landing poll. Let's take a moment now to introduce you to JPL Director Dr. Charles Alachi. Dr. Alachi, you have experienced Mars landings before. They are all nail-biters, but this one had to have been one of the toughest.
Yeah, absolutely. I mean, this was really so exciting, and things went so fast. But as soon as I saw the parachute actually open and was slowing down, I told Charlie Bolden, we're halfway there. And then it was just so exciting. It was like a movie.
So how does it feel to be back on Mars?
It feels fantastic. You know, at 9:15 earlier today, I went out, looked at Mars, which was setting. And I said, in an hour and 15 minutes, it's going to be different. You know, there's going to be the pre-curiosity landing and the post-curiosity landing. And this is exciting on behalf of all the world, NASA, the public. This is one of the most exciting things I've seen.
Absolutely. And what do you look forward to now?
Well, we're looking forward, now that we did this one, we're looking forward for the discoveries that this mission will make. We're looking forward for going again to Mars and continuing to go to Mars, going to Europe, go to all the planet. This is a mighty thing that our agency is doing for the American people.
A wonderful, mighty thing.
Absolutely.
Dr. Alachi, thank you for joining us. I'm going to let you go so you can go to your news conference. Again, we are expecting a news conference at about 11:15 Pacific time. And for those of you who have been trying to go to the NASA websites, we do understand that all of them have gone down because all of you have been going to them, looking for the images and looking for this coverage. There is one available. We have a super of the one remaining website that is available. Let me read that to you. It's mars.jpl.nasa.gov/MSL/raw. This is where you can see the images that just came back from Mars. Let's go back to the room.
And flight systems, we do not have the expected value. We have it as a value of 1, which is autonomous. And flight EDL, the sequence was changed late to execute a little later, so we missed that. Roger that. And power flight.
that our subsystem is currently nominal for step 27. For step 28, but the channel power 4007 last data point reads 1.56 amps. For step 29, bus voltage is last data point was 32.18 volts, roughly 93% of state of charge. For step 30, battery 2 current, last data point read is 1.57 amps. Step 31, power 4018, voltage reads 32.2 volts. Step 32, pyro 0120 reads 2491 ohms. Step 33, pyro 1120 reads 259 ohms.
Roger, copy power. And thermal, can you please report on steps 19 through 26? Roger that, flight. For therm channel 0768, the Reaper gas pressure, we have a pressure of 109.6 psia. For therm 0833, it's invalid data because it's the liquid channel on RPM B. For therm 2804, RTG1, we have a temperature of 142.1 C. For therm 2813, RTG2, we have a temperature of 127.6 C. For therm, confirm 127.6, is that right? Copy that. 127.6.
Well, we have good news. We are told that the website www.nasa.gov does have its images back. So several of the websites crashed because of all the people who are trying to see these first images from Mars from Curiosity. So once again, look at the screen. We do have the NASA.gov website back and also the JPL RAW website back up. Meantime, with me now is Lori Garber back again in the seat. So how's it feel for you? You went through the whole experience.
Well, we all did, right? We were joking that maybe Michael Phelps was the only one who could actually hold his breath that entire time. But there isn't anything more exciting. It's one of the reasons we do it. And I just congratulate the team. It's an amazing thing to have those pictures right now.
Could you believe that? You have them so soon and what you could see them in them.
The definition of that, and to recognize what the team went through and the challenges that they faced to do this and how successful they've been just so far. Let the science begin, right?
Let the science begin. Well, we'll be at this conference in just a short time. Deputy Administrator Lori Garber, thank you for joining us, and it's a good day.
It's a great day for America, for the world, for our future. So thanks.
All right. Thanks for being here. We'll go back to the room, into the MSA.
730.002, can confirm the EVR DMCA received to CLF. I can confirm that MCFSW was receiving good BIMU packets via the MCFSW status, which read X1100. And also the absence of any warning EVRs indicating a problem with continues. So as far as we can tell, DMCA was executing flyaway nominally.
Okay, copy that.
Well, the flight team is almost done. They are in the post-landing pole, and this is to say that Curiosity is safely on the surface of Mars, and the post-landing pole is kind of a symbolic handing over the keys of the rover to the surface operations team. They are operating in another room from here, just a short distance away from the MSA, the cruise MSA, and that's where the TV crew and I will be heading for the 12:30 a.m. show, or the commentary for the next Mars Odyssey downlink, which will have possibly even more pictures. Coming up next, the post-EVL news briefing at 11:15 Pacific time, just a short time away. This has been live coverage of the landing of Curiosity from NASA's Jet Propulsion Laboratory in Pasadena, California. JPL is managed by the California Institute of Technology on behalf of NASA. And again, you can continue to watch coverage. You can also see the images at www.nasa.gov, also our raw images. Meantime, I'm Gay Yehel. Thanks for watching, and we're on Mars again.
Okay, that was the news.